Hey there, so we're going to add in a couple more derivative rules, and today we're going to talk about differentiating with trig functions. So we've got our sine and cosine that I'll give you. We'll figure out tangent together, coming from Chapter 3, Section 4. So get yourself ready for notes, and we'll get started. So one of the nice things is that trig functions are always going to give you back a trig function. And we could show the work with limits. If you're interested in proving why these are true, I really encourage you to look in the textbook for where a lot of these rules are coming from. But what's really easy is that the derivative of sine is cosine, so they just change, and the derivative of cosine is negative sine. So the main thing here, and I'm using theta as my variable, but of course this would work here, is that our negative, if we look at the full table of all of them, which are later in your notes, you'll just notice that anything that's cos has a negative on it, and then the other ones are positive. So cosine is negative sine x, and then here are the rest. We are going to show how you can use these to find the other. So in case you don't have your notes with you, or we're back in person, you're taking calculus again later, Calc 2, and you're like, oh man, I know, usually students have just fine remembering these because sine becomes cosine, cosine, negative sine. But you can use those to then figure out the other remaining derivatives. So I'm going to show you how to do tangent. So the way that I'm going to solve this is I'm going to rewrite this as d theta of, instead of tangent, I'm going to write it in terms of sine and cosine. And now we have a quotient rule. So this is my f and my g. So then f is sine theta. G is cosine theta. We'll use the rules that I just did there, where f prime is equal to cosine of theta, and g prime is equal to negative sine of theta. Now, our numerator for our quotient rule is f prime g minus f g prime. And so then we get cosine theta times cosine theta minus sine theta times negative sine theta divided by g squared. So cosine squared theta, which we might just write like this. Now we can simplify that to cosine squared theta minus a negative, so plus sine squared theta all over cosine squared theta. Now hopefully this jogs some memories. These are the Pythagorean identities. Do you remember cosine squared theta plus sine squared theta is equal to 1? We also learned at the same point that 1 plus tangent squared theta is equal to secant squared theta, like so. And that cotangent squared theta plus 1 is equal to cosecant squared theta. So these are our Pythagorean identities. So in this case, we then get 1 over cosine squared theta, which 1 over cosine is the same as secant squared. So if you ever forget which the derivatives of tangent or secant, cotangent, these other ones, you can use the quotient rule. Because as remember, tangent is sine over cosine. Secant, as we just said, is 1 over cosine. Cosecant is 1 over sine, and cotangent is cosine over sine. So if you don't have these memorized from previous years, just put them in your notes so that you can refer back to them as you need to for this homework and using your different trig skills. So now in number 1, there you go. Here I've also included a table, which again, I just recommend having available and ready for you as you work through things. So we're looking here, we have our function and its derivative, so sine, derivative is cosine, cosine negative sine, tangent, as we just found, is secant squared. Secant is secant times tangent. Cosecant is negative cosecant times cotangent, so notice that they have similar processes, just co versus regular. And then cotangent is negative cosecant squared, just like tangent is positive secant squared. So don't want to memorize those. You can have that table nice and ready for you. So now with I just want to look at a slightly more complex version. So here we differentiate f of x, which is equal to tangent of x minus 1. And there's a couple different ways you can go about doing this. You can just use the quotient rule right away and call tangent of x minus 1 f and secant of x g. This is what I do in the PDF. Just to point out that there is an alternative, which is you can rewrite them in terms of sine and cosine. So then we have sine x over cosine x minus 1 all over 1 over cosine of x. And then we have this common denominator multiplied by cosine of x on both sides of the fraction like so. And then we have a lovely canceling here. Cancel when it's distributed. Here this cancels. And then it would distribute to there. So we end up with simplified version of sine x minus cosine x as f of x. So if you want to use the quotient rule, you can, or you can use some of your algebra skills, as we always talk about, to simplify first. And so then f prime, we just take each of those terms separately. Sine of x, as we talked about, is cosine x plus, because we have a negative, and then negative sine x. So f prime of x simplifies down to cosine x plus sine of x. If you want to see the quotient rule practice, that's in the PDF, but here is another nice sneaky way to get around doing that. If you have any questions, please let me know and set up any Zoom meetings that you want to talk about.